Now in these two problems, we're going to go both directions using the cylindrical and rectangular coordinates. In problem 373 here, we're trying to find the equation in rectangular coordinates when we're given the equation in cylindrical coordinates. And I've gone ahead and put the chart on here like I handed out in class, and we saw where it came from in the PowerPoint in the video. Also, I've already copied the picture of the answer, which is basically what they're asking us to do here, is to graph the surface. That just means we go type it in Maple or something, and you can do that just as well in the cylindrical coordinates as you can in rectangular coordinates. You don't have to change coordinates to draw the graph. But they do want us to come up with this equation, equivalent equation, in rectangular coordinates. So here's what we're going to do. We're going to start with this cosine of 2 theta. If we use the identity for cosine of 2 theta, it's the same as the cosine squared of theta minus the sine squared of theta. If we multiply this out, we get the r squared cosine squared theta and r squared sine squared theta, which is the same as r cosine theta squared and r sine theta squared, which is x squared and y squared. And then we have the z squared and the 1. Now that's an okay equation. If we put it in standard form, however, we can probably identify that surface. So if we move this 1 over to the other side, x squared minus y squared plus z squared equals -1. And then we change this to a positive 1 by multiplying through by negative. We have the standard equation. Now we can divide through by that 1, and so you can see, because we have the 2 minus signs here, that we have a hyperboloid. And we have 2 sheets. And sure enough, there's the graph of it. And on this one, we're going in the opposite direction. We have an equation here that's in rectangular form, and we need to put it in cylindrical form. So to do that, we're simply going to replace the x squared plus y squared with an r squared. We're going to replace the x with an r cosine theta, and then do a little work on that. Notice here we can factor out an r. And if we've got the product of two things equal to 0, either this one is a 0 or this one is a 0. And we can make this into a standard cylindrical equation by putting r equals 16 cosine theta. So it's either r equals 0 or r equals 16 cosine theta.